Okay, Martijn, so we can start. Good morning, everybody. Great to see you all here. And now, finally face-to-face after a few years. As you know, within OCA for the members, we have been running some task groups the last few years. And this morning, I would like to give you some updates on what these task groups did and how they are going. And I will start with the task group OCPP and filling stations. Now, why did we have this task group? Well, we all know that internal combustion engines are going to be phased out. There are even countries where they are no longer allowed to be sold after 2030. So that will lead to the effect that, filling stations will become a niche market if they don't start serving EVs. And we already see chargers appearing at filling stations here and there. But we also see that these charging stations are not integrated with the forecourt of the filling station. And that means, for example, that you cannot pay at the point of sales terminals for your charging. You have to use your charge card. And also they do not integrate with the retailer's back office. So we're looking at ways on how can you solve that. So what I would like to briefly discuss with you are the kind of questions that a retailer of a filling station might have. Like, for example, who's going to manage the charging stations? How can I integrate them with my forecourt systems? What payment options can or should I support? And how can I, for example, integrate a payment terminal? Well, first question, who manages a charger? As the entrepreneur that's running the filling station, the retailer, you have basically three options. One is you own your own chargers and you manage them yourself. Two is you simply decide to fully outsource the whole charging station business to a charging station operator. And the third option is that you have your own charging stations, but you contract a charging station operator to manage them. Now, I will briefly discuss each of these three options on how they work. Like this, better? Yeah. Okay, great. Okay, let's take the scenario where you, as a charging station, as a retailer, you manage the stations yourself. Then, of course, you need to have your own little CSMS on site to control your charging stations. It can be a fairly simple system because you probably only have a handful of charging stations, but you need to have a CSMS on site. And you need to connect that to your point of sales terminal. So then when the vehicle connects to the charger communicates with the CSMS. Your CSMS is connected to your point of sales terminal where you can start and stop the transaction and handle the payment. And then, of course, the driver pays you and all the revenue goes to the retailer. But it has basically two drawbacks. It is quite an isolated setup because your CSMS does not have roaming connections to a MSPs. You cannot support charge cards. And as a retailer with maybe one or a few filling stations, you probably cannot afford to have roaming connections with many different EMSPs or connect to roaming hubs because it's a costly affair. And the other downside is that as a filling station owner, you have to manage the stations yourself, which is probably not your expertise. So common solution to that, what we often see is that the filling station owner simply outsources it completely to a CSO. In that case, we have the CSMS from the CSO, and it's not integrated with the forecourt. Then you can basically only support the charge card charging. And what we see here is that, you all know the scenario, via the EMSP, the user charges, and all the revenue goes to the CSO. And the only thing the CSO does is pay you a location owner fee. Because as a filling station owner, you probably get a fee for letting the CSO place the station at your site. But you will not benefit from increasing EV usage because you still get the same location owner fee. And also in this case, it's not possible to pay in cash or credit at the point of sales terminal because there's no integration with your point of sales terminal. Well, there's a way to mitigate that, and that is the third option, where you have your stations being managed by a CSO. So as the retailer, you own the charging stations, so you get the revenue from the charging, but you request a CSO to manage them. And in that case, the CSMS is not yours, it's from the CSO. But the CSO has the roaming connections and everything to the outside world, so you can benefit from both situations. So you can support the payment at the point of sales terminals, where in this case, your point of sales terminals has a connection with the CSMS from the CSO, for example, via OCPI. I'll come to that in a minute. And then, of course, if the user pays it, you get all the revenue from the charging, and you just pay like a monthly management fee to the CSO. But you also have the advantage that you can do the charge card payment, in which case, I'll go to the bit quickly now, in which case the revenue that the EMSP pays to the charging station owner is paid to the retailer, and the retailer pays its management fee. So I think that's a very convenient option for filling stations, but of course you need to know how to integrate your stations with the forecourt. And there we have discussed two options in our filling stations task group. One is to use OCPI. The other one is to use a local controller on site. Well, first the integration option via OCPI. If you do an OCPI integration, that basically means that your point of sales terminal has an OCPI connection with the CSMS from the CSO. And I'll show it here. In the white paper, we discuss in detail, we show the exact messages that are being exchanged between the various systems if you use this scenario. I don't have the time to go into those details now, but you can download the white paper from our website. A disadvantage of this approach is that you are really depending on your internet connection. I mean, if you lose the connection with the CSMS because you have a network outage, for example, then charging becomes impossible at your station. So you really need to make sure that you have a reliable internet connection here. The second option, where if you use integration with a local controller, does not have this downside. Local controller, I mean, the concept is mentioned in the OCPP specification, but it's not really well defined what it does or does not. But it's basically a system that sits between the charging station and the CSMS that can act like a kind of proxy, just forwarding the messages, but it can also do some local things if you implement that. So in this case, the local controller that is on site at the filling station connects the charging station with the point of sales terminal. So in that case, for example, if you want to start charging at the charging station via a kind of authorized request, for example, it would request the point of sales terminal, it would request the cashier, okay, is this person allowed to start charging? And at the end, the user can pay at the point of sales terminal. And in the meantime, all transaction messages are also sent to the CSMS. But if you lose a network connection with the CSMS, then it will still work because the local controller is on site, probably hardwired, and it can still start and stop the sessions on the station and arrange payments via the POS. Okay, then we get into what kind of payment methods do you want to support. If we look at filling stations, we normally have these four methods, like postpaid, prepaid in the shop. You often have an outdoor payment terminal where you can use for unmanned stations, for example. And we have the regular fuel cards or tank cards. For charging stations, the most common way of payment is often the EMSP charge card. But we also show an increasing number of payment terminals connected to chargers. But then there are also two like automatic payment methods that are specific to the charging business, namely the ISO 15118 plug and charge and the auto charge method. But once you have this integration with your point of sales terminal, then you can also support postpaid and prepaid in the shop. So that gives your customer, every possible way to pay for the charging. And how then we get to the issue of how can I integrate a payment terminal with a charging station? And it becomes increasingly more important because in Germany now there's legislation that as of next year, that as of next year all public chargers need to be equipped with payment terminals. And also the European Union is thinking along those lines, where they want to mandate at least fast chargers to be equipped with a payment terminal, I think as of 2027. So it's really something that we need to take care of. And in fact, for OCPP, it doesn't really matter because OCPP does not describe any payment methods. It just requires a token that has to be authorized. So if you start using payment terminals, you could use perhaps a credit card number as a token, but if you don't want to share credit card numbers, you could use like an authorization reference that you get from the payment provider, use that as a token to show that it's authorized. So there's several possibilities there. And in our white paper, we describe 4 different methods that you can use to implement a payment terminal integration with stations. One obvious one is just via a smartphone app, like you have most EMSP apps where you can connect your credit card to it and then pay via that. That's not really integrated. But we also describe how you can integrate a payment terminal in the charging station. So then, more or less replacing the RFID reader and starting and stopping a session from within the charging station. Then there's the scenario of the outdoor payment terminal, where you have one payment terminal that might service 4, 5, 6 different charging stations. And then via remote start, stop, it controls the charging station. And our 4th option is that whereby the payment provider actually starts taking kind of EMSP role. So when your payment provider authorizes the transactions for you, then the payment provider issues an OCPI or other roaming call to the CSO to start charging for you. So there's basically 4 different flavors on how you can implement a payment terminal in your charging station. So all this has been published in the white paper, so you can look that up to see the more details on it. So if there are any questions about this topic, I will be happy to take them. Then I guess it was a clear story. I think Martijn needs sound.
Here we go. Let's see. Are there any questions yet? Also for the viewers at home, are anticipating new questions? Who dares to go first? One moment. I will check if there are questions from the audience at home. Let's see. We had some trouble with the video stream, but I think it's solved now. For everybody at home, please turn on the webcam option in the screen. Then you can see Frank. Let's see. Lonneke, did you have any questions coming in?
I think at the moment we don't have any questions from the webinar audience, so I think it was very clear. So thank you, Frank.
Great. Yeah.
Yes.
Thank you.
We will now go to Milan who will do the next bit of this session. If there are any questions left for Frank, it can go after this as well. Okay. Are we set? Yes.
I'm using this one. That's fine. Okay. My name is Mila Jansen, and I'm a technical editor for the Open Charge Alliance. And today I'm going to talk about the mode 1 and 2 only charging stations that we recently included for testing in our OCPP certification program. I'll explain in a moment what a mode 1 or 2 charging station does, but first I want to go over the certification program for those who don't know. In the certification program, you can certify your OCPP charging station or CSMS against the OCPP specification. This way you can guarantee to your clients that your OCPP implementation has been tested by an independent testing laboratory. And these are the different certificates you can get. So you can get a full certificate for the whole specification, or a subset certificate where you can implement core and pick and choose which optional feature profile you want to implement, for example, smart charging or reservation. And we also included a security certificate. So for OCPP 2.0.1, we included security, and we also backported that to OCPP 1.6. So you can also certify that. These are the testing laboratories where you can test and certify your OCPP implementation. We have 2 laboratories in the United States. The one in California will be available will be coming soon. And we have 2 in the Netherlands, 1 in Singapore, and also 1 in Korea. And we have 1 in Korea because we've seen a lot of activity there in the e-mobility market. So we also recently went there to the lab, KSGA, the Korea Smart Grid Association. And we had a meeting with several OCA members there, and they gave presentations. And one of them presented their new product, which was a billing outlet, which is basically a charging station which uses just a regular wall socket. Because they noticed that there's a growing demand in the market for a charging solution which just uses a regular wall socket instead of a 32 amps phase 1 or 3 connection, for example. So this is an example of such a device. I also brought it here with me because we got a question, is it possible to certify such a device as well? And yeah, this is a very good question. And we thought, why not? If it can communicate OCPP, then you should be able to certify it. But we needed to make sure that the current test cases were sufficient to also test with such a device. But before I go over our test results, I first wanted to go over there's several different charging modes. So I spoke about the 1 and 2 charging modes. The most, well, the one we're most familiar with, of course, is the mode 3 or the mode 4, so the AC or the DC charging. And for both mode 1 and mode 2, you're basically plugging your car into a regular wall socket. The difference between the two is that you have with mode 2 an additional in-cable protection device, which does several things, but basically there's an additional relay in there, and the communication between the device and your car will be mode 3, so there will be additional safety measures that you can actually see that a correct device is being implemented and it isn't drawing additional energy. So when you're charging a car, it will basically always be mode 2, and mode 1 can, for example, be used when you're just charging an electrical scooter or something. Then you could use mode 1. I briefly went over this already. These are the feature profiles, but we saw that for the mode 1, 2 charging station, that smart charging would not be a possibility because you cannot communicate your limit to the vehicle. I will go back to the previous slide because this device, where it's placed basically between the socket and the cable. So you can plug your cable into this device, which will handle the OCPP communication. So that's why this device cannot control basically the limits. And the rest of the profiles are possible, but in core we have a few exceptions, and I will go over them as well. The first one is there's no cable proximity detection. So when you plug in the cable on the charging side, for example, your charging station is not aware that there's a cable being plugged in. So there are several solutions to work around this, because we saw this before with older CHAdeMO models. Those were also not able to detect whether a cable was being plugged in. So we had discussions about this, how to work around this. One of the companies had a solution that it could have a sensor in the holster. So when you draw the cable from the holster, then it's detected, okay, it's now in use. So that's a solution. We have seen several mode 1, 2 charging stations that could had a sensor in the device itself, just a regular sensor that could saw, that it saw when you plugged in a cable, for example. This device, they thought of another solution. They started charging for a fraction of a second before authorization, and then they detected, oh, there's a cable, because the only thing you can basically measure is the power, and then they dropped it back to 0. However, the problem with that is when you unplug the cable again, you're not aware that the vehicle has left. So you need at least some kind of timeouts that you can set the connector back to available again. So there are several solutions, and we were just basically thinking about, okay, what kind of solutions would be allowed during certification. Another thing is OCPP described behavior when you unplug the cable on the vehicle side, and with this kind of charging stations, they don't know the difference between unplugging the cable on the charging station side or the EV side. There's no cable lock on the charging station side, so there's basically no difference. So we have 3 test cases that are testing the different behaviors of your charging station. So we picked 5.2, which is the one that was best applicable for these types of devices. The first part is there's no cable lock, so this test case supports that OCPP communication, similar to the behavior you would have with a fixed cable. And the transaction will end when you unplug the cable. because with no cable lock, you can just unlock your cable from both sides and then drive off, and the transaction will never end. So that would not be a good solution. So that's why we made this test case mandatory and the other ones not, because 0.3 is the scenario I mentioned before, the transaction will never end, and 5.1 is not applicable because there is no cable lock, which brings me to the next set of test cases, which is the unlock connector feature. So your CSMS will send an unlock connector request to your charging station, but there's no connector lock. So your charging station needs to state that it does not support unlocking the connector by providing status not supported. So that's why 17.2 and 18.2 are applicable, and one for both test cases, the variants are not applicable. So it's not that difficult, but you need to specify precisely which test cases need to be tested by the test labs. So here we needed to define a technical term for these kind of devices so that we could have a general scope where all these kind of devices are correctly described. So if your charging station supports only mode 1 and 2, which we defined here, we asked one of our members to help us with the technical terms and English, so he could describe it correctly. But this is also described in the certification documents. And this is the PICS you need to fill in before you apply for certification, so that your lab exactly knows what your charging station supports. And here we included a product subtype. So you can specify that your charging station is a mode 1 only charging station. So then the testing lab knows, okay, then these test cases are not applicable for this kind of system. So we already started, and currently we already have 9 certified mode 1 and 2 charging stations, all from Korea, because that's where we got a request and they already had their system. So they immediately, when it was possible, started certifying. And the reason in why it's also going so fast in Korea, because they get additional funds currently for having their systems certified. So that's why it's going very fast over there. Are there any questions? Maybe from online?
Thank you, thank you. We have questions coming in online, but I want to see the audience here first. Yes.
Okay. Since it is a normal household socket, what happens if you plug in a vacuum cleaner or something like that?
When you plug in, sorry, could you repeat?
Vacuum cleaner or something like that. Do you also need to swipe your card to use it then?
Yeah, with it depends on the device, but this device measures how much energy is flowing. So if there's less energy flowing, then it will not drop the current back to 0. Then it will just let it flow. So it depends on the device. If you have an air conditioner with the same amount of power, then it will ask you to provide your card. Yeah. But the solution is not for in your household. It's more like parking garages where they don't want to implement the high power, when they just have sockets.
Okay, thank you. Any questions from the live audience? Let's see. Here we have one more.
Thank you. Well, we're usually limited in current to 6 or 10 amps because of the thermostat plugs. The communication to the EV is still using the control pilot signal with the PWM and the duty cycle. So technically, the smart charging should be still possible.
Yeah, if you have, if the signal is being provided by your in-cable device, then you could still connect, but then this device needs to be built in the cable, which could be a possible solution, but that's not the devices we were provided by the Korean company. So they thought of this solution, but if there comes in another device that states you can do smart charging by that, but in that case, they will bring the cable. So maybe it could be if there's a fixed cable, but yeah, then you get a bit, that you cannot use the socket anymore for other solutions. So we would have to see what kind of solution they thought up, but I don't see the business case currently for that.
Okay. Let's see. Any questions from the audience? Because we have waiting people here online who are anxious to get their answers. Let's see. Regarding mode 1 charging, is there any protection you require inside the charging measuring device? And are they also available outside Korea?
Not sure if they're talking about this one or, I mean, the cables with the in protection device are just, you can buy. Paul also has one, which I used for my testing. So the protection is basically in there. This device doesn't have any protection. It expects that there's a device in the cable that does it for it.
Okay.
So this is basically only OCPP communication and authorization and nothing more.
Yeah. For a mode 1 charger, if we want to enable smart charging feature, how should we proceed forward?
Yeah, that's basically very similar to the question I received.
Mm-hmm.
You either need to communicate with your in-cable device and make it a whole solution, or you need to sell the cable as a solution. So yeah, that depends a bit on that.
Okay. It's very detailed, perhaps. On page 11, there was a communication mode. Is JSON mentioned? Which other kind of modes are still used?
The charging modes, you mentioned JSON?
I don't know. I don't get more specifics than that. I don't know if you know it by heart, but on page 11, it says communication mode is JSON.
Yeah, I know it was selected, but I was talking about the product subtype. So the communication here is a selection box, because for OCP 1.6 you can choose between WebSocket JSON or SOAP with XML.
Oh, okay.
So you can still test for SOAP as well, but most of the charging stations currently in the field are JSON. And for all certificates we provided, there was no SOAP implementation. We only have JSON WebSocket implementations.
Let's see if I understand some correct. If the charging is in progress and the user unplugged the connector without stopping the transaction, how will OCPP handle such a scenario from the backend?
Yeah, so on the car side, it is in most cases locked, and on the charging station side, it's not. So there is a scenario described for this in the specification, but normally this is a fault situation because you cannot unplug it from the charging station side. But basically, it will see it in the same way you would have unplugged it from the vehicle that doesn't have a connector lock. And there were some vehicles in the past that where that was possible, but that's not safe. So I would have to look at the exact OCPP communication, but basically the transaction will stop and it will provide the reason, EV communication lost or something, and you will get some error warnings.
Okay. let's say, imagine if I want to control this charging capacity via different charging profiles for different times of the day. Is that possible?
Not with this device, but yeah, similar to the previous questions. Smart charging is not possible. Then you will need an in-cable device to do the smart charging for you.
Okay. How can the in-cable device communicate with a CSMS? Via which medium would it happen?
Yeah, so like this device, then you would have a combined device that is able to speak OCPP via Wi-Fi, for example. Otherwise, it will not work.
Okay. Let's see. I'm looking at the live audience. Are there any questions here left? Oh, one in the front, two in the front. One moment.
Could you guide me through the use case of such a device? So it's not for home, but it's for parking garages? Or?
Yeah, we had some discussion about this internally as well. In Europe, they don't see a business case for this because it seems a bit as a step back. But in Korea, in the cities, they don't have much space and they don't want public chargers. So basically all the charging happens in all the parking garages for when they go to work and go home, their car is parked in a public parking garage. And basically they don't want, there are parking garages, of course, where they thought about it and set up just a regular mode 3 charging, but they see they cannot provide enough charging for all the cars in such a short amount of time. So this is, I think, a in-between solution to be able to charge, start charging quickly. And they don't mind that it takes longer because they are a whole day at work or they can charge the whole night.
Okay, so it's more of an intermediate solution. But is there any kind of protection locking mechanism in play for such a device? So let's say I charge my car, can someone just pull the plug out? Because
yeah, someone could plug out the cable, but like I mentioned with the test case for 5, we are mandating that the transaction will end at that moment. So it's not possible that someone will plug in his own car and start charging on your cost. So we thought about that, of course, but they can unplug your cable. But in Korea and in Japan, they will not do that. So and we're also a bit surprised, but what they also have is just a button to stop charging. And we in the Netherlands only have emergency buttons, and people will not press it because they're dangerous, red, and maybe in glass encased. But they don't swipe their car to stop charging. You can just press the button. And we were saying, okay, but what if there are some children and just pressing all the buttons for fun? Oh, no, that doesn't happen here. So
thank you.
Yeah, so my question was more or less, have you seen this implementation outside of Korea? I guess you more or less answered it already.
Well, in the past, but it was a bit different. There was not a device that was communicating OCPP. You could just plug it in at home and start charging on your own power, and you don't need any OCPP communication for that. But yeah, in Korea they wanted it. So this is apparently there are business cases there, right. But I haven't seen it outside of Korea as of yet.
Thank you.
Okay, thank you. We will be wrapping up this part with Milan, so we can give the stage to Lonneke.
So welcome everybody. My name is Lonneke Driessen and I work with the Open Charge Alliance. and I have prepared a short presentation on the OCPP development and the market needs. So in the presentations of today, you will learn about the ISO 15118-20 support, about vehicle-to-grid, about more advanced networking capabilities, about filling stations, all these different types of new features in OCPP. And at this presentation, I'd just like to share with you 4 sort of market developments that we see as Open Charge Alliance. Because as you may know, the Open Charge Alliance is an industry alliance, and when the industry provides us with input that they need something or that they are missing something in OCPP, we work to add it to OCPP. So we always listen to what the market needs. So what we see with the market of EV charging, that there are all different types of developments, and they are not all necessarily evolving in the same direction. So for instance, here you see to the left side, you see sort of advancing technology. The megawatt chargers is one development that we see that also needs OCPP support, charging at 1 megawatt and even more, charging large vehicles. You see a market request for plug and charge, ISO 15118-2-20, which sort of makes the whole charging session more advanced, but also more complex. And of course, the bidirectional charging, not just for the consumer, but also for grid support. So there are use cases being implemented and companies that want to use electric vehicles to support the grid frequency or provide reactive power. So really advanced uses in e-mobility. But at the same time, we also see a development for improvements and growing of EV markets, but in a sort of almost different direction. So Milan just presented the mode 1-2 chargers, low-cost chargers. This is also what's coming in the future, and it's not as complicated as bidirectional power flows for voltage support, but it's still a market need. Another request we have received from India, they are considering maybe a prepayment system for EV charging, and that is currently also not in use, for instance, here in the Netherlands or in Europe, but it is something that other markets are considering. So where we maybe in the past assumed that it was sort of a linear development. Everybody uses OCPP 1.5 and then 1.6, and then everybody moves to 2.0.1, and everybody keeps growing at the same pace in the same direction. What we see is because OCPP is used all over the world, the applications and the development speed and the development direction is also very diverse. And of course, well, that's fine. So in our alliance, we try to accommodate all the needs, so the needs in India, in Korea, but also the frequency support and bidirectional trucks and all the more complex use cases. So this is one development that we see, that it's not just a linear route, everybody moving in the same direction. So the second important market need that we know of is the demand for backwards compatibility. As you know, OCPP 1.6 is not compatible with 2.0.1. And this is causing a lot of questions. We get this question a lot from companies who are starting in OCPP, and they're asking us, so where do I start? So do I start with OCPP 1.6 to have maximum interoperability in the current market? Or should I start with 2.0.1 because it has the most elaborate feature set? And they struggle with this question, and a lot of the times they want to have both. So they want to have and the maximum interoperability in the market, and they want to have the feature set. So that's why you see why companies are requesting 15118 support for 1.6 or even vehicle to grid for 1.6, and companies are trying to combine both. Well, with 1.6, the features that are there are somewhat limiting you in moving forward. So in some cases, we publish this combination. So there is an application note on how to combine 1.6 and plug and charge, but it's not a full ISO-2 implementation that you can support. So this is why we will moving forward. So we can't change the past, but with the 2.0.1 implementation, we see that the basics are well put in place. So from now on, we can make sure that all the future OCPP versions are backwards compatible. So a 2.0.1 charging station will work with the 2.1 system and vice versa, and from now on. So this is something that we really see that there is a need. Also because a lot of our participants are experiencing the market growth. So they have so many tenders that they can apply to. They have these huge ramp up challenges, and they're really asking us for us to help it easier for them to accommodate all the new features that are coming and keep coming. So what is our approach? So first of all, and all this is being discussed in the technology working group, but the basic rules we have is that all the 2.0.1 functionalities shall remain valid for OCPP 2.1, of course, future versions. We, of course, will no longer introduce breaking changes. And the next versions shall only add new features. And the two examples that you are aware of is the ISO-20 support and also V2X, not only for -20, but also for CHAdeMO. And the approach that we are working at is to have a minimum effort for implementers to achieve this interoperability. So as an example, if you are developing a 2.1 charging station, you only need to support the provided 2.1 schemas to be able to operate under a 2.1 CSMS. And the other way around, if you have built a 2.1 CSMS, if you still want to communicate to 2.0.1 charging stations, you only have to implement the additional schemas. So this is from now on the approach, and all the details are being discussed in the technology working group. And tomorrow we have a face-to-face meeting, and there we also will go more into detail. But this is something that we is one of the most pressing requests we hear from the industry. So the third development, we see that there is a certification program in place for 1.6. It has been in operation since 2019. And the companies that came to the certification labs, the numbers were quite low. You can see how many there have been so far. You can see on the OCA website, you can see the list of every company that is ever certified. And you can, if you do the math, it's not that much. But what we see is that since apparently the market doesn't certify spontaneously, you see that there is more and more obligation to certify. And here you see 3 examples. So from left to right, you see that the California Energy Commission has recently mandated OCPP 1.6 or higher certification if you want to have access to funding. So it's not a mandate that every charger should have it, but if you want to have access to funding, you have to certify. And particularly for that reason, there is a 6th certification lab opening in California. Because of course we expect that in California, due to this regulation by the Energy Commission, there will be a lot of requests from vendors to certify over there. And in the afternoon, we have a presentation from the certification lab, and there we will also have more information on this new facility in California called Vigil. That's the name of this initiative. So in California, you see that the California government is mandating certification. As an example, in the Netherlands is the city of Amsterdam. When they purchase charging stations for Amsterdam, they also require a certificate. You have to have a certificate, otherwise, yeah, you can't sell to the city of Amsterdam. And the third most prominent example is in Korea, where the Ministry of Environment also has coupled the access to government funding to OCPP certificates. And this has been a huge boost for the certification program. If you go to the OCA website, you will see that there are a lot, more than 100 certificates that have been issued to Korean companies. And also, as I mentioned this afternoon, we will give our thanks and all hail to the Korean lab, who has worked really hard over the past few months to get all these certification runs done in time before the deadline of the ministry. So this is what we see in these parts of the world, and this is something, a development of last year, this year. So this is something that we also see as a market, yeah, the way the market is moving. And then the last thing we see more and more prominently is the debate or the desire by utilities to control smart charging. So what we see not only in Europe, but also in the United States, that utilities are becoming more and more vocal about directly controlling the charging sessions to balance the electricity grid. And one prominent example is in California, where the requirement, if you want to do bidirectional power flow, so you want to provide power back to the grid, you should the converter should comply with this specific IEEE standard, which identifies 3 different protocols. So it basically says that utilities should have direct control over the inverter, but with AC vehicle to grid, the inverter is inside the vehicle. So does that mean that utilities will have direct control over the vehicles? So for us, this is still a bit puzzling. So we're trying to figure out, so what is this regulation exactly? How will this work? And how will this work together with OCPP? That is part of the work that we've started recently, and we'll also be discussing in the technology working group. But it's something, this is a specific example in California, but you see that more and more popping up where utilities are sort of getting a little bit concerned. We